Okay, in this video we are going to look at ionic bonds first, and then we'll have subsequent videos which would cover covalent bonds and molecule structure and molecule shapes, etc. So ionic bond, let's start with this. First we need to answer why atoms combine, why atoms bond together. In the periodic table, the most stable elements are in the group 16 here, and every atom is trying to gain similar stability, and they can gain that kind of stability if they have electronic configuration similar to these noble gases. So bonding is nothing but an attempt on the part of atoms to acquire electronic structure, electronic configuration of noble atoms. Let's take a look at electron configuration of noble atoms first. So helium we have here, it has only 2 electrons in its first shell. Next one is neon, which is atomic number 10. In the first shell it has 2, in the second shell it has 8 electrons. Next one is argon, atomic number is 18 and electron configuration is 288. Next one is krypton, it is 2, 8, 18 and 8. And let's take one more, it's xenon, the electron configuration is 2, 8, 18, 18 and 8. So we note that in noble gases, the outermost shell has 8 electrons, other than helium, of course. So outermost shell is also known as the valence shell. All noble gases other than helium have 8 electrons in its valence shell, and this is the characteristic that makes it stable. So all atoms, when they combine, they are trying to gain this electron configuration. They are trying to gain a full octet in their valence shell. Oh, sorry, wrong spelling here. They're trying to gain a full octet in their outermost shell. Now they can gain this kind of full octet in their valence shell in 2 different ways. The first way is by complete transfer of electrons, either giving up electrons or taking electrons, and this gives rise to ionic bonds. The other method they use to gain this octet is by sharing, and that is the basis of, and that leads to covalent bonds, which we will discuss in next video. So let's take a look at few examples of how atoms acquire octet by either giving up or acquiring electrons. So let's take a case of sodium. Sodium has an atomic number of 11 and its configuration is 2, 8 and 1. When we compare sodium with the electron configuration of noble gases here, we see that sodium is very close to neon here. So only difference is that sodium has got 1 extra electron here. So the easiest way for sodium to acquire electron configuration of a noble gas, that of neon, is by losing the swing electron, and that would make turn sodium into a positive ion. The reaction, if I think we can write an equation for that as well. So sodium will lose an electron and it will become a positive ion, and positive ions are basically known as cations. So sodium becomes a cation. Yeah, and when it loses that electron, it is left with electron configuration of 2 and 8, which is similar to the electron configuration of neon here. Let's look at another element here, this time on the one from the right hand side of the periodic table. Let's take the case of chlorine. Chlorine has an atomic number of 17 and its configuration is then 2, 8, 7. When we compare chlorine's electronic configuration with electron configuration of noble gases here, we see that it's quite similar to that of argon. So only thing that chlorine needs to do to gain electron configuration of a noble gas is to acquire an electron. So if this 7 becomes 8, then chlorine would have electron configuration of that of an argon. Yeah, and when chlorine acquires an electron, it becomes a negative ion, which we also call anion. So equation that we can write is, this is chlorine, it combines with an electron, and it gives rise to this chlorine ion, which is an anion. If you look at both these reactions, you see these equations are balanced with respect to atoms as well as with respect to charge. So if we take a look at this equation first, on the left hand side the total charge is 0, and on the right hand side you got a 1 positive charge, you got a 1 negative charge here, so total charge is 0, so it's balanced. And likewise in this equation as well. Let's take one more equation let's take one ionization of one more element before we talk about before we go any further. So let's take the case of oxygen. So oxygen has got an atomic number of 8, electron configuration is 2, 8, 6. Again, when we compare oxygen with oxygen's electron configuration with electron configuration noble gases there, we see that this electron configuration of oxygen is quite similar to argon. Argon has got 288, oxygen has got 286. So the easiest thing for oxygen to do is to acquire 2 electrons, and when it acquires 2 electrons, its electron configuration becomes similar to argon, which is 288. So the equation that we need to write is this: you got oxygen, then you got 2 electrons there, and that converts oxygen into an oxygen ion with 2 negative charges. Okay, so let's look at what happens when sodium and chlorine combine. Now, one thing we need to keep in mind here is that when one atom is giving away electron, there should be another atom, another species available to accept that electron. Any atom cannot give away electron just as it is. There need to be some other species there, some other atom there, which is willing to take that electron. Otherwise, the electron would not be donated. So when sodium and chlorine combine, first we have sodium, which gives up an electron and becomes a sodium, wrong spelling, which becomes a sodium ion, and you have chlorine here, which accepts that electron. So basically that electron goes here and you get chlorine minus. So when these two ions, they are oppositely charged, one is positively charged ion, other is negatively charged ion, they have a very strong force of electrostatic attraction between them, and because of this strong electrostatic force, they are attracted and they are held together, and this is ionic bond. If I have to write it, I think I would be ready to write this down. Ionic bonds are formed when two or more, I think I'll just write two oppositely charged ions are together by strong electrostatic force of attraction. So now, because of the very nature of the force with which these ions are held together, we can guess many of the properties of ionic substances. So the first thing is that we see that the ionic substances do not form molecule; they form a continuous 3D lattice structure. And like in many cases, for example, you have water molecule. A single molecule has its own existence, whereas in case of ionic substances, what we have is a continuous 3D lattice structure. So you have an arrangement of oppositely charged ions here. This is your chlorine, that one is sodium, and they are arranged in this manner, and all of them are held together very tightly by strong electrostatic force. So we do not have a molecular formula here, but we have a formula, but it's not molecular. Likewise, when we apply this, we have been talking about molecular mass, but we see that molecular mass is not relevant to ionic substances because there are no molecules here. Instead, what we talk about is formula mass. So this is the term which is more relevant to ionic substances. So formula mass is the mass of one formula unit of the ionic substance. So for example, we got sodium chloride. The formula is sodium chloride NaCl, and when we talk about formula mass, we talk of the mass of sodium, one formula of sodium chloride, one formula unit of sodium chloride. So this is 23 plus 35.5. Yeah, this is very important. Then second, then looking at the very nature of the bond with which these cations and anions are held together by strong force, we can understand many of the properties of ionic substances. Ionic substances are hard, and obviously they are hard because these, as we saw above, that these positive and negative ions are held together very tightly, so it's difficult to break and difficult to deform them. That's why these are hard. They have high melting and boiling point. They would obviously have high MP and BP, because when we try to boil or melt substances, we are trying to separate these ions, positive and negative ions, and these positive and negative ions are held very tightly, so we need to provide a lot of energy to separate them, which means that their melting point and boiling point is very high. The next one is that they do not conduct electricity in solid state. To conduct electricity, you need two things. One thing is we should have charged particles, and other thing is that these charged particles should be free to move. They should be mobile. In metals like copper and iron, we have electrons as mobile charged particles, and these mobile charged particles, mobile electrons, then conduct the electricity. In ionic substances, we have charged particles, positive and negative ions, cations and anions, but they are very held together, they are very tightly held together, very rigidly held together, and they are not free to move, so they do not conduct electricity. What would happen when you melt them? When we melt ionic substances, then these ions, cations and anions, they become free to move. They are free to move within the matter itself, and therefore they conduct electricity. Same is the case with ionic substances in solutions. In solutions, you have cations and anions which are free to move within the solution, and they conduct the electricity. Last property is that these ionic substances are brittle, and it could be understood like this. For example, we have sodium chloride ions held together like this. So you got chlorine against sodium, and again you got sodium against chlorine, and like this. When you move one of the layer here, one either left or right by one unit, then we have similar charges coming face to face, and these similar charges, when they come face to face, they repel each other and they break apart, and that basically explains why ionic substances are brittle. Now we got this. Now I think we should look at a few questions for practice. Okay, I think something was already there. Okay, so I would want you to stop the video first and pause the video and try to attend these questions. So first one is, I'll do one or two questions from here, one or two problems from here, and then I would request you to do other questions, remaining questions on your own. So first thing is, we have to write ionization equation of these elements. So we have already looked at oxygen, but we can give it a go. Oxygen atomic number is 8, so electron configuration is 6. So when oxygen wants a full octet in its valence shell, it needs to gain 2 electrons here, and then it becomes 2, 8. So oxygen's ionization not exactly, wouldn't call it ionization, but oxygen would become an anion when it gains 2 electrons, and that gives rise to your oxygen ion. Let's look at question number 2. Again, what I would want you to pause these videos, or pause the video for a moment and try these questions. So I'll be doing only one from here. I'll be doing only 2 from here. So let's look at calcium and oxygen first. Calcium has got, I'll do them here. Calcium has got atomic electronic configuration of 2, 8, 8, 2. So calcium becomes an ion by giving up these 2 electrons. So equation that we can write for calcium is calcium becomes, it acquires 2 positive charge by giving away 2 electrons. Then we got the oxygen here. Oxygen atomic configuration we already saw here, and oxygen needs 2 electrons. It becomes O2 minus. So we see that calcium is giving 2 electrons and oxygen is accepting those 2 electrons. So these equations, both equations are sort of complete when taken together. So what we have is, we have 1 atom of calcium and 1 atom of oxygen combining together, and we have calcium oxide formula as CaO. Next thing, we can look at sodium and nitrogen here. Sodium, we already saw sodium has got a configuration of 281, and therefore sodium would gain a full octet in its valence shell by giving up this electron. So we have sodium giving up its electron like this and forms an ion with single positive charge here. Nitrogen here has got atomic configuration, electronic configuration of 2,5, which is atomic number 7. So nitrogen need to gain 3 electrons here, then it becomes 2,8. It gains full octet in its valence shell. So nitrogen plus 3 electron forms an ion with 3 negative charge, 3 units of negative charge. But here we see that when taken together, these 2 equations are not balanced. Why? Because sodium gives up only 1 electron and nitrogen needs 3. So we need to have 3 atoms of sodium, which makes 3 ions and gives up 3 electrons. These 3 electrons goes here to the nitrogen. Therefore, when they combine, there will be 3 atoms of sodium would be combining with 1 atom of nitrogen, and the formula would be this. And that's where we'll stop today.